All right, let's talk about that massive wall of text every IT admin has stared down at least once. We're taking that chaotic output and transforming it into a clean, easy-to-read, highly actionable diagnostic X-ray. I'm talking, of course, about the Dsregcmd/status command. Listen, if you troubleshoot Windows Hello for Business, EntraID, or Single Sign-On, this command literally answers more questions than any cloud portal ever will. By the end of this explainer, you're going to know exactly how to read it from top to bottom, totally sweat-free. Okay, let's dive right in.
We have all felt this specific IT pain point, haven't we? You're staring blankly at a command screen, basically just guessing at why a user can't sign in seamlessly. And the craziest part? The actual answer is sitting right there, completely hiding in plain sight. It is beyond frustrating to know the data is right in front of you, but you still end up spending an hour just chasing your tail.
And here is exactly why that happens. Running Dsregcmd status just dumps out a massive wall of over 60 fields. No labels, no helpful context, just data scattered across 7 different sections. The unfortunate truth is that most of us just scan for the 3 lines we actually recognize and skip the rest. But you know all that critical info you're scrolling past? That is exactly where the solution to your headache lives. But hey, before we decode anything, we've got to talk about the absolute biggest gotcha with this command. You absolutely have to run it as the signed-in user. Seriously, do not run this from an elevated command prompt. If you run it as an admin, crucial user context fields like nzcset and AzureAdPRT, they're going to show up as blank or completely wrong. And if you do that, you'll end up wasting hours chasing fake problems that don't even exist. Always run it in the user context first. So here's our game plan for this explainer. 1. Decoding the wall of text. 2. Device and tenant status. 3. User and SSO state. 4. Diagnostics and NGC checks. And 5. Behind the numbers. Section 1. Decoding the wall of text. Let's establish that identity. It's funny how this command actually simplifies the most fundamental question. What kind of join are we even looking at? Right at the top, you get 3 simple yes or no fields: AzureAdJoined, EnterpriseJoined, and DomainJoined. It's a basic truth table. For example, if AzureAdJoined is yes and DomainJoined is yes, boom, you have a Microsoft Entra hybrid join device. Memorize this logic, because half of all your troubleshooting is going to start with just getting this join type right. Section 2. Device and tenant status. Let's look at identity and endpoints. Down in the device details section, you're going to spot a field called thumbprint. Now, don't ignore this. It's not just a random string of characters. It's the actual device certificate's thumbprint, and it perfectly matches the exact registry subkey under Cloud Domain Join info. That registry spot, that's where all your device details live. It is the literal anchor in your registry, proving exactly where the device identity exists. Let's rapid fire through a few other crucial indicators here. TpmProtected. Yes means the private key is safely locked in the hardware TPM. Then there's device auth status. If this reads failed, well, that immediately explains a whole category of sudden sign-in drops. Tenant ID just confirms you're actually talking to the correct Entra tenant. And curb spawn. This one is huge. This proves if Cloud Kerberos Trust is actually in play. If it's populated, your tenant is configured for it. Section 3. User and SSO's state. This is the true heart of the output. Smack in the middle of the SSO state section, you'll find AzureAdPRT. That's your primary refresh token, and it is the absolute core of the user's single sign-on state. If it says yes, Cloud SSO is present, it's healthy, you're golden. But if it says no, you have 0 SSO for anything, and you can fully expect that user to be hammered with constant password prompts all day long. Now let's connect some other vital user fields to those real-world headaches you get tickets for. ngset reading yes means Windows Hello is successfully provisioned. ngKeyID is wild because it literally matches the exact NGC folder name on the local hard drive. Then you have WAM default set. This actually brokers your SSO to Office apps. If this is missing, Office will demand passwords even if your PRT is perfectly fine. Finally, an on-prem TGT reading yes is absolute proof that a Cloud Kerberos ticket for on-prem resources was successfully acquired. Section 4. Diagnostics and NGC checks. Time for the hidden gems. Buried way down in the diagnostic data is this incredible check called KeySignTest. When you run the command, Windows actually performs a live TPM key signing self-test right then and there. If this reads failed, the underlying cryptographic operation is just completely broken. It's an amazing metric because it catches a failing hardware TPM issue way before Windows Hello itself even realizes there's a problem. Now, if Windows Hello hasn't actually provisioned yet, you're going to want to look at the NGC prerequisite check section. You'll see fields like, is device joined, is user AzureAD, policy enabled, and session is not remote. The big takeaway here? The very first no you see in this list is your exact answer for why Hello didn't set up. Oh, and watch out for session is not remote reading no. That is a classic trap. Windows Hello will never provision over an RDP session, so if you're testing remotely just to save a walk down the hall, it's going to fail every single time. Section 5. Behind the numbers. Let's talk about the services driving the OS. You know, at the end of the day, this command output is really just giving you a live read of the background services driving the OS. So we can map these abstract fields directly to the Windows services you need to fix. If your KeySignTest fails, go check the Key ISO service. If your PRT says yes, but apps keep prompting for passwords, check Token Broker. A failed device auth status? That points straight to Crypts VC. And if on-prem TGT is no on a hybrid KeyTrust device, look at NetLogon. Seriously, no more guessing. The command tells you exactly which service is dropping the ball. So what if a field does look wrong? Well, that's where the user device registration log in Event Viewer becomes your best friend. It tells you exactly when and why something failed. If a prerequisite fails, look for Event 360. If device off status reads failed, that's going to be Event 362. And if ng set unexpectedly reads no, you want Event 363, which means the passport key is just missing. The command shows you the symptom, but the event log, that shows you the history. All right, let's bring it all together and summarize this diagnostic playbook. When you run dsregcmd/status, you're going to read it strictly from top to bottom. Step 1, check the join type. Step 2, verify the device key and TPM. 3, confirm your tenant endpoints. 4, validate ngcset, the primary refresh token, and the ticket granting ticket. And step 5, read the diagnostics and prerequisite checks at the very bottom. Following this structure narrows down the exact issue every single time. So we've totally dismantled this command. By treating this output like a structured map instead of just a wall of noise, you have the power to pinpoint the exact failure in minutes. My final question to you is this. Are you ready to use this map and completely stop guessing at Windows Hello and SSO issues? Take this new X-ray vision, apply it to the very next broken hybrid device that hits your desk, and just watch how fast the answers reveal themselves. Thanks for hanging out with me for this explainer, and I'll catch you in the next one.